absolute value of x minus 6, and then is greater than or equal to 2.
Good. So which type of absolute value inequality is this? The easy one or the difficult one? Right. So we have to separate into two inequalities. Is this inequality already fully simplified? Always remember, you must redo the problems we do in class first. If you redo the problems we do in class, we can move forward faster. If you don't do the problems, we'll always go back and back and go back and go back. So, is this completely cleaned up? Yes, good. So what are the two options here?
X minus 6 greater than or equal to 2.
Awesome.
And then x minus 6 less than or equal to negative.
Awesome. So it's the outside. Greater than or equal to 2, less than or equal to negative 2. Very good. I move negative 6 to the other side. I move negative 6 to the other side. And all I have to do is write the union. So how do I write the union? Can anyone give us the answer?
This is where I get sometimes confused is I know how to read it to be able to like either the bracket first and then the
Unions, the infinite are always
no, like,
open. You always have to start in this situation, you always start from the left, and you always have to start with negative infinity. If there is an equal symbol, you have to put a bracket. If there is no equal symbol, you will not put a bracket.
no, I understand the bracket and stuff. It's just I don't know when to. I just like always start with negative infinity.
Correct. And you have to put this first because this one stops at 4. And you have to continue with this one because this one starts at 8.
What did you just do?
Yes. Hold on just one second. Wait.
Sorry. How did you added 6 to both sides, then you subtracted 6 on both sides?
Can anyone tell us what we did?
I didn't see
So
it.
you add 6 to, like, say you add 6 to,
2.
yeah,
Right.
and it becomes 8.
Right.
And then you add the 6 to that side, and
That's
it's
a
negative
4, okay.
7.
We always learn when explaining what we're doing to other people. It's the best way to learn. So find a grandma, find somebody, your neighbor, and teach them what we do in class. You're going to feel so much better about it. Yes.
It's always negative infinity, like the first number.
But if it's less than 4, where do I start?
Okay. Just negative infinity.
And the answer is, it's always the outside. So I always have to start from negative infinity. Okay. It's the outside. It's not the inside. This type of inequality, it's not the inside. And if it's the outside, I have to start a negative infinity. Very good question. Yes. Anything else? Anything else?
I don't have a specific problem.
Yes.
But, like, taking the square root, like for factoring. Like,
Yes.
there's a lot of them on the homework.
But factoring and taking the square root are two different things. Factoring is one thing. Taking the square root is something completely different. So please do not put those two together.
You know how in the chapter, I think it was 1.5.
Yes?
I heard that part. It was like factoring, and then it was like the different methods on how to solve it.
So solving quadratic equations, we have 4 different methods.
Yeah, that.
But factoring is one thing. Taking square roots is something
Okay,
else.
then it was taking the square root.
Okay, I'm ready.
Oh no, wait. I don't have a specific problem. It's just I was getting stuck a lot
On
on that type of those type of problems.
which one?
Taking the square root.
So when we take a square root is basically the easiest type of situation. Why I call it the easiest? Only because this is specific for taking square roots. Right?
Mm-hmm.
I'm not going to square, get 3 terms and add 4 to both sides. Because this is way more difficult. But right away, I take the square root and I get this. And then I get this by moving negative 2 to the other side and becomes positive 2. So then 2 plus 2 is 4 and 2 minus 2 is 0.
Okay.
So taking square roots, I would say, if it's already set up. Now, if it's not already set up, then it's more difficult because I need what? I need to complete the square. So it takes much longer. But if it's already, the square is already completed, this is the easiest method to apply, I would say. but I'm not sure whether this is what you had in mind. Is this what you had in mind?
No, because that was easy. I did that.
So can you find a problem so we don't stall?
Okay.
Was it completed the square, maybe?
Yeah, I think it was completely the square because that.
Okay, so can you give us a problem that you worked on so we can clarify it? Do you want me to make one up with complete the square?
Yeah.
Okay, so let's say x squared minus 8x plus 7 equals 0. So this is a quadratic equation. Let's say we are forced to use complete the square. What did I say about complete the square?
Yeah.
Never,
It
right?
was-
So let's say, that's one way of putting it. It's because why? It alone does not do the job. We need to use the taking square roots method after I complete the square. So the method has 4 steps. What is the first step?
Identify the coefficient.
Excellent. The middle coefficient is negative 8. Let's divide it by 2. Negative 4. So then we square negative 4 and we get 16. So then I have x squared minus 8x plus 16 equals 16 minus 7. Now some students say, well, why don't I move the 7 first? You can't. I just did it in two steps in one. Same thing. So now I know that this is a perfect square now. So, and 16 minus 7 is 9. So what is the perfect square on the left? And this is what we did in the first day of classes because as you see, it pops up constantly. So what do we have on the left? Can anyone tell us what we have on the left?
X minus 4.
Of course, what we squared to get 16, of course. And now I have to take the square root. And this is x minus 4 equals plus or minus 3. And of course, we move negative 4 to the other side, it becomes positive 4. And we get 2 options, 7 and 1, indeed.
I think I just made it.
Yeah, so as I said, the method is very useful. Not really for quadratic equations. 4 plus 3, 4 minus 3. Good. Other questions for me? Anything else before we go back to chapter 2? Yes, please, Priscilla.
Mu 3x squared minus 14x is equal to 5.
3x squared minus 14x equals 5.
And I think for the homework assignment, it said to use the quadratic formula, but I wanted to see, can you use the completed square?
Correct. I did not show a similar problem like this. Whenever the leading coefficient is other than 1, there is an extra step in there. I did not show a problem like that. Did you find a problem like this with the other leading coefficient but 1, asking you to complete the square? Those of you who already finished, Mana, did you have a complete the square with the leading coefficient that was not 1?
I don't remember.
No, I don't think there was, but I can show you. So first we have to divide both sides by 3. I will not put a problem like this on the test or final exam. So then you have x squared minus 14 thirds x equals 5 thirds. That's the very first step. You cannot complete the square if the leading coefficient is not 1. So even if 3 is not a common factor, you are forced to divide everything by 3 to make the leading coefficient 1. And then the rest of the steps are identical. So you still have negative 4 thirds divided by 2, negative 14 thirds divided by 2, which is negative 7 thirds. You square, you get 49 over 9. And that's what you add to both sides. So that's an extra step. I did not show a problem like that. If you want, I can continue, or we can move on to chapter 2. Okay, other questions for me? Anything else you tried or you had difficulties with? Anything? Anything? Okay, perfect. So let's go back to 2.1. And I'm looking at what we covered last time from 2.1. We know how to identify functions using bubbles. I call them bubbles. They're not bubbles. They're Venn diagrams. But so from here, we know which one is a function. And let's refresh our memory. For each x, there must be only one y. Function, not a function, a relation. This set is the values of x. This set is the values of y. So obviously, even a relation has domain and range. Domain, the set of x values. Range, the set of y values. Also, we identified from a graph. So we can be given different graphs. Can we identify which ones are functions and which ones are not functions? The answer is yes, using the vertical line test. Here, by the vertical line test, it hits any vertical line, hits the graph in 1 point, function. But here it does not. It hits the graph in 2 points, which means it's a relation. Does it have a domain and range? Yes. Even a relation has domain and range. So this was a problem from the book, and we identified the domain and range from a graph. So let's go back and look at some more problems from that. And here is some, I'd like to go back to the same problem. I think it was 85, but let's choose another. Let's choose 82 this time. So here's the graph of 82. Okay, so it's very clear that the domain of this function is from the leftmost point to the rightmost point measured on the x-axis. So it's from -6, but it's an open point. So it's going to be a parenthesis at -6 till 0 for the vertical line x equals 0. Since this is a full point, the domain will be -6 with parenthesis, 0 with a bracket. Now what about the range? From the lowest y value of this function, which is -3, with a full point, to the largest y value, which is 4, with an open point. So bracket at -3, parenthesis at +4. Now, what if I ask, find f of 2? What would you say? 2 is here. Function undefined. Function does not go at 2. The domain is from -6 to 0. If I want you to determine a function value, I have to stick with a domain, right? So now let's say I want to ask you f of -4. What would you say?
0.
Correct. So it means x equals -4. This is the vertical line, x equals -4. It hits the graph at this point, and I will read the y value, which is 0 on the y-axis. What if I want f of -2? I draw a vertical line at -2, and I would be reading the y value here. Can you give me just an idea?
2.
Anything you say, I'm going to have to accept because it's difficult. So -2.2, -2.2, fine. Do you all understand how to read from the graph? Okay, so if I say f of -2, I'm given x. If I say f of 0, what will you say? -3. You draw a vertical line, x equals 0, it hits the graph at -3, that's the function value. Does this function have x-intercepts? I see you're playing with your cell phone. It was on the table first, now it's under the table. So
It's my key.
oh, okay. I just don't want, I want people to pay attention. That's all I care about. My apologies. Okay, so is there an x-intercept?
Yes.
Okay, is there a y-intercept? Excellent. 0, -3. The x-intercept, -4, 0. Very good. What can you say about this function? Because I'm going to ask you later in the next section. Can I say that this function for x between -6 and 0 is always decreasing?
No. Yes.
So between -6 and 0,
Yeah.
is the function
Oh, yes.
always decreasing?
Yeah.
Yes.
Is it ever increasing? No. Is it ever constant?
No.
Excellent. Okay, what if I ask this now? Find x for f of x being 1. What am I given now? Very good. The y value being 1. Y equals 1 is a horizontal line. X equals 5 is a vertical line. So y equals 1 is this line. Does it hit the graph?
Yes.
Yes.
What is the x value where it hits the graph? Excellent.
What was the question you asked?
What is x? I'm going to put it in writing. What is x when f of x is 1? So I'm not given x, but I'm given y. So y equals 1. And it crosses at this point, and I will be reading the x value, which is negative 4.5. It's not, but I'm not really interested in absolutely accurate number. Okay, so let's put that in writing for this function. So this is function 82 on page 231. Oops, no one can see anything, of course. Okay, 82 on page 231. So the domain, one more time, was -6 to 0. The range was -3 to 4. X-intercept, -4, 0. Y-intercept, 0, -3. F decreasing on all its domain. I'm preparing you for something that follows. What else we said? We said find x such that f of x is 1. And we said that x was -4.5. And if you want, can anyone tell us which ordered pair did we read from?
For y.
Yes, for this one. I just want to write the ordered pair.
-4.
Thank you very much. Thank you. Awesome. Thank you. I appreciate it. Good. What else we said? Find, what was that? F of -2. And what did we say? I forgot. Of -1, I think we looked at. And what did we say? -2.2. Was it? I think we looked at -2, actually. And it was -2.2. Can anyone give us the ordered pair?
-1.
Yeah, I'm sorry. I went back and forth twice. My apologies. Sorry about that.
You got the error, you can't decrease, right?
Yes, yes. F is decreasing. The other one will be like this or constant. So we're going to look at those later on. Any questions?
Excuse me.
Yes.
What does it say? What does it say in this the corner right there? What's the first thing at the bottom? I just can't read it. It's like R. Find this one. Oh, it says find. Okay, sorry about that.
That's like find x side.
Yeah.
What did I say?
Find
In the
f of
box.
-2.
No, in the box.
Find x such that f of x is 1. Sorry, my handwriting is never going to be perfect. I'm standing and I'm writing, so my apologies for that. Okay, so we can read a lot from a graph. Any questions here? Any questions? Okay, what if I have a graph like, I want to look at 92 for a second. Just want you to see 92. I lost it. Where is it? Okay, here it is. I really like this. Here, it's helping. Okay, so here's a function. Oh, by the way, is this a function? Oh, I forgot to ask you about the previous graph. Was it a function?
Yes.
Yes, by the
Vertical.
vertical test was a function. What about this one? Is this one a function? So for x equals -5,
Oh, okay.
Yes.
for x equals -2,
Yeah.
for x equals 0,
Yes.
it hits only once, right? For x equals 1 and for x equals 4, correct? Okay. Is this a function? Perfect. Can anyone give us the domain of this function? Notice that you cannot connect these points. The function is given as is, and that's it. That's all we have. So it is a function by the vertical line test, but what is its domain? And how would you write it? What is the first x you see? Yes. -4, comma. I'm sorry, -5, comma. -2, comma. 0. We're talking about x. 0, comma. Comma. Excellent. That's the way we have to write it, with commas. Not parentheses, not brackets, because not everything is there, right? For a bracket or parentheses, everything inside exists. But if I want to find f of negative 3, what will you say? How much is f of negative 3?
Undefined.
Excellent. That's the correct word. Undefined. The function is not defined at negative 3. So you cannot say it's a bracket or parenthesis between negative 5 and 4. That would be incorrect.
So the numbers that you just said.
With a comma.
With a comma.
Yes, I'm going to write it in a minute. So please give me the range of this function. Yes, please, Lani.
Because it doesn't have lines, is that why you do that?
Because it's not connected.
Oh, right. It's not connected by.
Correct. Yes. Yes. A line or something else. Yeah, it could be something like this. Correct. So what is the range of this function? Exactly. Only negative 2. There is nothing else. If I ask you find x for f of x being 2. For f of x being 2, what is x? It doesn't exist. There is no x, right? For f of x being 2, the horizontal line does not hit the graph. Do you all see it? Okay, very good. So now let's write what we just discussed. So you have it in writing as well. So for problem, this was 92. On 232, so we have the domain with braces, no brackets or parentheses, because they're not connected. Yep, yeah. So negative 5, comma, negative 2, comma, 0, 1, and 4. The same thing with the range, just negative 2. For any finite number of values, we have to use braces. Okay. Okay, we move on to 2.2. More information, more ideas about functions. And I want to go directly to problem 52. So let's see. Can we all see the graph? Yes? Okay. So what can I say about this function? A lot. Oh, by the way, is this a function?
Yeah.
By the
Yeah.
vertical line test. What can I say about it? A lot.
Yeah.
A lot. Can anyone give us a domain? Notice one thing. There is an arrow here, and there is a full point here. So what would you say about the domain? From negative infinity till
Actually, it's 6.
to positive 6, with the bracket at 6 and the parenthesis at negative infinity. I'm going to write it down so I don't forget, and then I'll show you. Oops. One page went away. I got it back. Okay, so this is problem 52 on page 251. Domain from negative infinity you set till 6. I completely agree. Okay, so now let's identify the range of this function. Say it again.
Negative 1.
There is an arrow here.
Negative infinity.
Negative infinity
to 1.
till 1. Very good. So from the lowest y value to the largest y value. Negative infinity to 1 with a bracket. Okay, now let's talk about the trend, or what we see here, in other words. I see what type of trend first? Increasing. Then I see a constant, and then very good. So I will say now that f is increasing on, and you'll give me the interval. F is constant on, and then f is decreasing on. We're not interested, when we talk about the increasing trend, we're not interested from what value to what value, no. We're interested in where does that happen for the x values. It's increasing whenever x is between, yes, with a parenthesis, however. F is increasing on negative infinity to negative 2. What will you say, when is the function constant? Very good. in parentheses, -2, 2. And where is this function decreasing? For only for which x value, not from what to what. We don't care about that. So this is like saying somebody's salary increased between 1990 and 2000, was constant between 2000 and 2010, and increased again between 2010 and 2019. We are not discussing from what value to what value, okay? Just the trend. So what is the trend of decreasing on between 2 and 6? Very good. On 2 and 6. Okay, let's see if we answered domain. We answered. Okay. Now, next question about the x-intercepts. We have two ways of talking about, more than two ways, but two are present in your book. One of them is called finding the x-intercept. The second one is finding the zeros of a function, when the function is 0, in other words. So what are the x-intercepts of this function? Right, -3, 0 if you want to present it as an ordered pair, and 3, 0. So x-intercept, -3, 0, 3, 0. What about the y-intercept? Does this function have a y-intercept? 0, 1. Very good. Y-intercept 0, 1, because we have to write x first. Perfect. Let's see whatever intervals we read. Okay, they are asking us now to find f of 0. I draw a vertical line, x equals 0. And I read the y value, right? X equals 0 is the y-axis. It crosses, right. It's the same thing. Very good. 0, 1. Let's see what else they want.
You said the x equals 0?
F of 0. Yes. So when we have f of x, it's the function. When we have f of 0, it means x is 0. Maybe I should emphasize that. Oh, everything is written down. Yes, yes. Values of x for which f of x is positive. So here's another idea. Forget about the question for a moment. I'm looking at this graph again, and here's what I discovered. I discovered that the graph is below the x-axis for values between -infinity and -3. Would you agree? So if I want to determine f of -4, will it be a positive number or a negative number? Right. If I want to determine f of -5, will it be a positive or a negative number? Because the function is below the x-axis. Now, do we see that the function between this point and this point is above the x-axis? Which means for any x value that you were asking me, find f of 0 or f of 1 or f of 2, the function value would be positive, right? F of 0 is 1, f of 1 is positive 1, f of 2 is positive 1, f of -1 is positive 1, and so on and so forth. Now, what happens after 3, from 3 to 6? It's again below the x-axis, which means that if I ask f of 4, you're going to give me a negative number. If I ask f of 5, you're going to give me a negative number. If I ask f of 6, you're going to give me a negative number. So here's the question. They want us to find x such that f of x is strictly greater than 0. Not equal to 0, but strictly greater than 0. What will you say by looking at the trend? So it's greater than 0 here, but they don't want equal to. So for which interval is this function positive, but not 0? It's always positive between -3 and 3. We established that. But if I write -2 and 2, then I miss infinitely many real numbers. You understand it? Because between -2 and -3, we don't have a long enough life to mention those numbers. So it's -2.001, -2.0001, -2.00, and I will never get to -3. It will not be time enough in this lifetime. Okay? So if this is greater than 0, it's between -3 and 3 without using a bracket, because they don't want the equal symbol. So the answer is x in the interval -3 and 3. Like this. So f of x greater than 0, x must be We have to pick x between -3 and 3 to make sure that f of x is positive. And I think there is f of 4. They're asking, is f of 4 positive or negative?
Negative.
Negative, it's right here. F of 4 is right here. It's a negative number. So f of 4 less than 0. What else they want? They want values of x for which f of x is -2. F of x equals -2. So, careful.
Oh, wait. Oh.
F of x equals -2. F of x is -2. That's a horizontal line. It crosses the graph in 2 points. I would be reading -5, and I would also be reading 5. So f of x equals -2 means x equals -5 and x equals 5. Can anyone give us the ordered pairs that we read from?
Can you repeat that one?
Yes.
Can you repeat that one? The
So,
F of
yes,
two.
I'm asked, yes. The problem is asking us to find x when f of x is -2, which means y equals -2, which is a horizontal line. Y equals -2. So I drew or imagined that I draw
Oh, I see.
a horizontal line, y equals -2. It crosses the graph in 2 points, and I read the corresponding x value.
Okay, got it.
Better? Okay. What do they want? Okay, there are 2 other items that I have to come back because I didn't teach them yet. I will teach them right now. So there are 2 more questions and we'll come back to it. So now let's go back. Let me show what I wrote so you can copy this. So here they are. And I'm going to indicate which one is which part right now. Okay, domain was part A. So domain between -infinity and 6. Are we okay with that so far? Stop me if you have questions anytime. Part B was the range. Part C, the x-intercepts, also called zeros of f of x. So that was part C. X-intercepts, -3, 0, 3, 0, also called the zeros of f of x. X-intercepts or the zeros. Part D was this. F of 0 was 1. Part E, function, intervals on which the function is increasing. This was E. Function is increasing on the interval -infinity to -2. Part F, the function is decreasing on the interval 2, 6. Decreasing on 2, 6. G, f is constant on the interval -2, 2. This I edited myself, so I'm not going to name it. H. Find the values of x such that f of x is positive, and we discussed that x has to be between -3 and 3. Values of x for which f of x is -2. It's on the next page. So that is I. Is f of x positive or negative? F of 4, I'm sorry. That is J. And we discussed that f of 4 is negative. And we have to come back to K and L after I explain a few things.
What did I say after the y equals -2 under there?
Horizontal line. Y equals -2 is a horizontal line. So we drew, or we imagine we draw a horizontal line at -2, and it crosses the function in 2 points, and we read the x values. Okay. Any questions so far? Any questions?
What does that KE stand for?
We did not get the chance to.
Oh, okay.
I have to present material before we go back to answer K and L. We cannot do it just now. Any questions? Any questions from the previous page? So domain and range. This was the y-intercept. I already wrote it. I did not. They're not asking us for the y-intercept. I wanted to make sure that we understand. We were asked to find f of 0. We're asked to find the function, the x values when f of x is -2. So now 2 new concepts. Here's a new concept that we haven't discussed before. You may have seen it before or not. It's called relative, max, or min. So here's a graph of a function. We're going to see this graph in chapter 3. So I'm going to just put some values here. I'm going to say 4 and 5, 10, and 4. This point and this point are also called relative extrema. Relative extrema. Plural from extremum. Relative extrema. What does that mean? At these points, the function exists, and I can show with a little interval around them. For the first one, I can show that all function values are smaller or bigger than this one. Smaller or bigger function values around that point, left and right of that point. Are those function values smaller? Of course, because this point is called a relative. Right. So this point is a relative max. Because I can show a tiny interval on both sides. If the function does not exist on one side, it's not a relative max or min. But I can show with an open interval that all these function values are smaller than this one, which is 5. So this is 4, 5, a relative max. What do you think the point called or labeled 10, 4 will be? Why will it be a relative min? Because first of all, the function exists on both sides. And I can show the tiny interval around that point where all function values left and right are definitely bigger than that one. So this function value here is definitely bigger than 4. This function value here is definitely bigger than 4. So this point is called a relative min. And it makes sense. Let's look at the graph one more time. What does the function do before x equals 4? Correct. What does the function do after x equals 4? So what does the function do after 10? So obviously when the function is increasing and decreasing, if it's increasing and decreasing, that's a relative max. If it's decreasing and then increasing, that's a relative. So coming back to our graph, there are 2 schools of thought here. Some say they use the equal symbol. Some don't use the equal symbol. So, is this function increasing here? And then it's constant. So I can show you the calculus book in which they say all these points, this one and all these, are called relative max. Because the left and right can also be equal. In this book, they say no, the left and right cannot be equal. So they say there is no relative max. I want to show another graph because I still want to determine relative max and relative min. And we can look at other problems, of course. So what will you say about this graph? Obviously, it's increasing from negative infinity to -2. And then it's decreasing from -2 to 0. and it's increasing from 0 to 3. I don't care about y values. I only care about the trend. And it's decreasing between 3 and infinity. Does it have a relative max?
Yes.
Actually, it has 2, correct? So this is a relative max, increasing, peak, decreasing. So what are the coordinates of relative max? Negative 2, 4. 2 questions we have to understand here. When we're asked where is the relative max, I have to give position. If I'm asked how much it is, I have to give the altitude. So where is that local max? It's also called local or relative. We interchange those. So where is that relative max? When x is negative 2. How much is it? Right. So what about this? It's a relative min. Where is it? How much is it? Perfect. So what about this one? The third one. Relative max. Where is it? X equals 3. How much is it? 2. So you understand the 2 questions. What is the position? Where? For what x? In what year you had the highest salary? Right? For what x? And how much was it? That's the y coordinate of that point. Okay. Any questions about relative max, relative min? Yes?